Hello, I'm Patty, and today I'll be talking to you about math and its importance in the medical field. Although they seem like two very disparate subjects, math is actually becoming increasingly important in the understanding of the human body, and it is being used every day by medical professionals. But how? Let's start with ratios and proportions. They're mainly used by nurses when administering medications and calculating dosages for a patient. The equation used for this is, amount of medication on hand to the quantity you have is equal to the desired amount to X. For example, let's say a patient is being prescribed a liquid medication. The doctor's order and desired amount is 210 milligrams once a day, and the information on the medication label says that 1 milliliter, which is the quantity we have, is equal to 70 milligrams, which is the amount on hand. How many milliliters should the patient be administered per day? Let's look at the equation. The amount of milliliters that the patient will be administered per day is represented by X. Let's solve. Next, we have probability. Probability is the calculation of the likelihood for an event to occur. It is usually used by geneticists when determining the inheritance of particular traits in an organism. To determine the probability of inherited traits in an offspring, geneticists will often use a Punnett square. Of course, this one is pretty simplified, but it's good enough to get the idea. First, name the variations of the gene or alleles that are involved. In this case, we'll use eye color. Let's say that one of the parents has blue eyes and the other has brown eyes. Now we have to check the parent's genotype. Each parent has two alleles and they can be dominant or recessive. For this problem, the blue eye trait will be heterozygous, meaning that it has one dominant allele and one recessive. As for the brown one, it will be heterozygous recessive, meaning that both alleles are recessive. Let's apply these alleles to the Punnett square. To find the possible outcomes of the traits appearing in the offspring, we'll start with the first box. It will inherit one allele from each parent. Look at the letter to its left, then to the one above it. Fill that in, and repeat the same process for each box. Now let's interpret the Punnett square. There are 4 different possible outcomes, which means that each combination has a 25% chance to appear in the offspring. Since there are 2 dominant recessives and 2 recessive recessives, we can confirm that because 25% plus 25% equals 50%, there is a 50% chance for the offspring to have blue eyes and a 50% chance for the offspring to have brown eyes. Last but not least, calculus can also be applied in the medical field. Calculus is a branch of math concerned with continuous change, and it can be used to make sense of processes such as the motion of fluids. In the medical field, calculus is applied to the study of the heart and cardiovascular system. In our example, we will be using Poiseuille's law to calculate the flow in an artery. The equation is F equals pi PR to the 4th power over 8NL. Here, F represents the flow or flux, P represents the pressure difference from the ends of the artery, R represents the radius of the artery, N represents the viscosity of the fluid, which in this case is blood, and L represents the length of the artery. Let's say that in this problem, the values are P equals 3,850 dynes per centimeter squared, R equals 0.01 centimeters, N equals 0.019, and L equals 3.2 centimeters. Now to calculate the flow in the artery, we just need to plug in the values into the equation. The answer to this equation is around 0.00025, so we'll need to convert this into scientific notation, which will finalize our answer as 2.5 times 10 to the negative 4th power cubic centimeters per second. This is the amount of blood that is passing a point in an artery every second. Overall, it can be concluded that although they may seem like two very disparate subjects, mathematics and medicine can intertwine in various ways. Ratios and proportions are used to calculate medicine dosages, probability is used to determine possible genetic traits in an offspring, and calculus is used to calculate blood flow in an artery with Poiseuille's law. Without the usage of these methods, as well as many others, so much knowledge we currently have about the human body probably wouldn't exist. Just imagine how many discoveries medical professionals can make in the future by continuing to apply math in their research.